recording button. So now this call is being recorded, and I will give the floor to Alastair.
Awesome, thank you. Would it be possible, I think the share screen button is, there we go. Okay. Technical difficulties. I actually don't seem to be able to, let me move this window. There we go.
Okay.
I found it. Awesome. Thank you, everyone. And thank you for the introduction, Benoit. And yeah, thank you for everyone who's attending today. I really hope we can get something useful for everyone. My name's Alastair. I'm the tech lead for Android Emergency Location Service. And today we're going to be talking a little bit about matching emergency communications with AML or ELS, and remembering that ELS is Google's implementation for Android devices of the AML specification. And so there we go. So kind of as a high-level goal here today, we're hopefully going to understand how to effectively match ELS AML data to emergency calls. And you may be asking at this point, why is this important? Well, one of the key goals that we have as the ELS team is to ensure the highest level of reliability and quality of emergency location during emergency calls being provided to our public safety partners. And so hopefully some of the insights that we're going to be giving you today are going to be able to help teach you a few things, and maybe, you know, hopefully give you a bit of some food for thought to maybe take into your roadmaps for the next few months, as you will soon see. And so, yeah, quickly, our agenda for today, I'm going to give you a little bit of a background on where ELS is at in 2022. We're then going to talk a little bit about the different methods of transmission of ELS data, and then we're going to start deep diving a little bit further into HTTP. And I'll explain all of this as we go. And then we're going to be having a case study from Henning. Really excited about this. This will be hopefully able to give you a real-world example of why this is valuable and those kind of things. And then after that, we'll talk a little bit about what you can do next to get started. You'll hopefully all be really excited about getting on board with some of the proposals we're making today. And yeah, we'll also leave plenty of time at the end, hopefully, to have a bit of a kind of, you know, roundtable, offer some chance for questions and for even any feedback that you all might have for us on what may be good and bad about these proposed solutions. So yes, let's quickly go into ELS in 2022. And so we're going to start with just kind of reiterating, we talked a lot about this at EENA, but I just wanted to make sure it's clear. The goal of the ELS team, this is our mission statement. So we want to enable Android users to get help from emergency responders more effectively wherever and whenever they need it. And so there's a few key parts to this. It's effectively, we really want to make sure that we can get the right data to the right people at the right time. And the wherever, we want this to work no matter what your situation. You know, people call emergency numbers in all kinds of various scenarios, and we want to make sure that our solution is flexible to all of these various use cases. For example, different levels of data connectivity, roaming, all of these various edge cases. And yeah, the effectiveness stuff, like we can, you know, AML is a really great spec, and it gives some of those the basics like location, but we also want to start going beyond just your kind of classic XY location. And I'll talk a little bit about that shortly, and how more information we can get from the mobile device to the emergency responders to help you do your job of helping users when they make emergency calls. And so I imagine a lot of you know about ELS already, but it's always good to have a quick recap just to remind you of the kind of the model that we have here. And so ELS, what happens? So when an emergency call is initiated, the Android device will detect the emergency call for regions where we are launched. Once this happens, we use the on-device fused location provider. This is Google's kind of module built into Android phones that helps fuse all kinds of signals from the device, for example, your GPS, Wi-Fi, and other various signals to be able to get the best estimate of where you are. And then from there, this location and other additional information can be sent directly to the public safety partner. It doesn't go to a Google server, and the endpoint can either be an SMS endpoint or an HTTPS endpoint. And so SMS means we would just send a text message during the emergency call. HTTP, very similar, but we would send an HTTP request to some kind of web server. And so once it leaves the device, this is where Google's responsibility sort of fizzles, because it's now up to the partner to take this data on and try and make it available to the emergency responders relevant for this given emergency. And so from there, as you can see, we're very interested in the whole end-to-end here. We want to help as many people as we can, but as you can see, it's quite hard for us because we live on this left-hand side of the diagram. And so one of the things that we're always interested in doing is getting feedback from the partners on what we can do on our side to help you get your job done to the best way possible. And so how is ELS looking today? And so this is a bit of a zoomed in view on Europe. As you can see, we're doing pretty well. It's a pretty green little map, and it's very exciting to see such great adoption in Europe. And a huge shout out goes to EENA here for helping drive this adoption. And it's great to have so many of you on board as partners. And I think breaking down into this data, something I also want to call out on the right-hand side of this screen is the ELS transmission method. So for 75% of this is actually for the world, but it's mostly for Europe actually. SMS is the main method of transmission. And this is fine because, you know, a lot of these emergency call centers have telephony equipment set up already. And so it does kind of make sense going with SMS for a lot of cases. However, only 22% actually use SMS and HTTP. And you might be wondering, okay, what's the problem? Like SMS, we're going to be getting the location. And we're going to deep dive into in the next section on, you know, the pros and cons of both SMS and HTTP. They both aren't perfect, but they both bring different things to the table that hopefully can help. And in some very rare cases, ELS is launched with just HTTP. So what are these methods of ELS transmission? And most importantly, why does it matter? And so here's a little kind of diagram that we drew up. And as you can see, we've got all of these kind of different features that are either supported or not supported. So going through these quickly, we've got basic location information. Both SMS and HTTP will be transmitting your basic location information. That is your XY coordinates along with a confidence on the map. This is obviously one of the most critical pieces of information, and both of these different protocols support this. Now, what we also are starting to move towards now is something we like to call as advanced location. So this is actually going the next level from your XY and maybe introducing newer concepts, for example, altitude. Unfortunately, this is not yet supported on SMS. And the reason for this is because the SMS messages are actually quite limited in the size of the packets. And so unfortunately, altitude is not shipped with SMS today. However, in HTTP, we will also send information about your altitude and the accuracy of that given altitude. And if you're interested in learning a bit more about vertical location, we actually did a presentation at the EENA conference this year, which I think you can view on YouTube to learn a bit more about the values and benefits of having vertical accuracy. I can actually show you it here as a quick kind of overview. You know, we can give you we can give you these things, and it can take your search space from this big orange kind of circle here to actually bringing it down to just this small limited set of maybe potential floor levels in a building, which can be really crucial in big built-up cities. In addition, we're even prototyping things like location floor, where we're attempting to send the actual label of which floor we believe the user might be on. Okay, the next one we're going to talk a little bit about is additional data. And so additional data, this kind of encompasses a bunch of various technologies that are coming to smartphones these days. And so the most common two that we talk about are language and car crash. And so I'm going to quickly show them here. And so what are the benefits of these? So device language, as you know, sometimes you might get emergency calls where you can't understand the language of the caller. The benefit of having this additional metadata is you might be able to find the translator quicker. So it might tell you a list of languages that the user is able to support. For example, in this example here, it might tell you that they speak English, and French. In addition to that, we're also starting to expand these with things like car crash detection. So on devices that can automatically detect a car crash, we will send this kind of extra metadata along with the emergency calls so that the emergency responder might understand why this call triggered. And we've got lots more additional data that unfortunately we're not going to share exactly today, but there's a lot more things coming in the next 12 months that we can't wait to share with you that are going to be coming to HTTP. And so, as you can see, there's a lot of rich data here that can be potentially taken benefit of. We're also then going to talk a little bit about latency. So SMS on average is around 8 seconds latency. Unfortunately, though, SMS has a long tail. And so what this means is actually, yes, 8 seconds on average, but in a lot of cases, SMSs can actually get quite clogged up. A lot of SMS infrastructure in the world is unfortunately quite old, and therefore it sometimes has, latencies of maybe a minute we've seen in the past through testing. Whereas HTTP, as you know, when you go to a website, often if you have a good internet connection, it can appear pretty much instantly. And something as a reason for this is actually HTTP is still a very, very small packet that's being sent. It's not using a lot of the user's data up. It's, an order of kilobytes. So really quick and has that benefit. Then let's talk about error rates. So SMS, the error rates can be good. There's often a lot of work here in debugging the error rates. So often when countries launch, there can be issues in the underlying SMS infrastructure of the mobile network operators. For example, there are cases where sometimes SMS can't be sent during emergency calls due to legacy system reasons. And often these issues can be troubleshooted, but it can take a long time and you have to work directly with carriers to make this happen. HTTP, however, as long as the smartphone is able to go on the internet, this is almost never an issue. And this is similar with roaming too. One of the challenges of roaming is the SMS has to ping back forward through different countries based on where you actually based in the SIM card. And you can actually look at our EENA 2021 talk to learn a bit more about roaming, but it's genuinely quite complex to get roaming working for SMS at a high quality. Now, that said, one of the great things in Europe, as you all know, is that you can roam between countries generally and still use your initial country's data plan. And so these days, it's becoming increasingly more common that users, as they travel around Europe, will have access to the internet. And so this is where the roaming really comes into its, the HTTP can also really come into its own. And as you can see there, I think there's a two times lower error rates we often see in general. And then let's quickly talk about the complexity. SMS, setting up an SMS center is often quite complicated. You often have to work with mobile network operators, and sometimes there's even costs involved in setting up these kind of infrastructures. Whereas HTTP, it's quite a simple server. It's actually just a simple web server that you can hopefully deploy either on a local machine or on some kind of cloud platform. Device network requirements. So SMS has the benefit actually that it doesn't need data. However, and it should just work on any cellular connection. However, it won't work if you're only connected to Wi-Fi. So when you're deep buried in buildings like offices, this can sometimes be an issue, or underground. On the other hand, HTTP does require data connectivity. However, it, often being connected to a simple Wi-Fi point is enough. And so there's a lot of benefit here. And also something to call out, like I say, the amount of data usage is actually very, very low for ELS over HTTP. And so generally, it's not a huge issue that you're eating up the user's data. However, it is a lot harder. I will call out that it's a lot harder to zero rate, make a URL free than it is to make an SMS number free, which is something that some countries are able to do with SMS. So there are pros and cons here to both of those. And then contains phone number. So this is actually uniquely a problem with HTTP. Unfortunately, devices don't always know their phone number, and I'll talk a little bit about that in the coming slide and the actual impact of that and how you can get around it. Great. And so yes, so these challenges with HTTP. So as I said, the missing phone number problem. This is when the number, the device, it's called device number in the spec, is just simply missing. And this is because the way phones know their phone number is often dependent on the SIM card. And so it can be very dependent on conditions of the device, for example, the way it's set up. And this can mean that countries can vary from having 100% of users knowing their, almost 100% of users, like devices knowing their phone number, to actually more realistically, more around the 50% mark, especially in a lot of Europe. And so this can be a big challenge. And this is something Henning's going to be talking about a bit later. And we are working on improving this. We're really hoping to see some improvements in the coming years. But this is where matching really comes into its own. As I mentioned, connectivity is really hard. It is sometimes a challenge, specifically if you want to zero rate URLs. However, like I say, it's only small amounts of data and you actually get the benefit of Wi-Fi as well. And then in terms of infrastructure, you know, this might actually change some of your underlying infrastructure, especially if you're already deployed with ELS. And so understanding some of the challenges here, and I'm hoping Henning's also going to be able to talk a little bit about how you can get around some of those challenges of updating your existing technologies. And so finally, I'm just going to say, we believe the best solution is both. It's actually the hybrid approach. And this is where you have both SMS and HTTP set up. And what you can then do is you can match on IMEI so that you can get the benefits of both for each other. Henning's going to be talking in a lot more detail about how this works, particularly with respect to improving the dynamic phone number, the missing phone number problem. But as mentioned, SMS has benefits in certain levels of data connectivity. And similar, HTTP has different benefits, for example, Wi-Fi. SMS has the benefit of always having a phone number, but HTTP is often faster, works better with roaming, and has more information. And so there are really pros and cons to both. And if you can get a system that's utilizing both of these technologies, this is the best way to improve the efficacy of ELS for your users. So from there, I'm actually going to hand straight off to Henning, who's going to talk about a real-world use case of this kind of hybrid approach.
Yeah, thanks, Alistair. Benoit, can you give me the presenter mode?
Sure, leave me 1 second. It's hard to find you, there's so many people connected. Yeah, now you should be able to share your screen.
Okay. Yes, as Alistair said, I will present a case study how AML and ELS is implemented in Germany, especially with HTTPS. So we have the advantages of both. After the case study, I will lead over to Alistair again, and then we have time for questions at the end of the session. Yes, my name, I'm Henning Schmidtbott. I worked as a call taker and dispatcher in the PSAP of Freiburg for many years, and today I'm responsible for the technology. Sometimes I'm still working as a call taker or dispatcher, but very seldom. So that's a presentation. Okay. First, I want to say some words about how emergency calls are handled in Germany. In Germany, we have 2 national emergency numbers. We have the 112 for fire and rescue and emergency medical services, and we have the 110 for the police. AML at the moment is only deployed for 112, so I'm talking about 112 only. In Germany, we have 16 federal states, and we have 233 PSAPs handling 112 calls. Each PSAP is independent in their organization, their technology. So, for example, the CAD is a CAD system. Of course, some PSAPs have guidelines of the federal states, but most are independent. And on the map on the right side, you see that's Germany, and that's areas of responsibility from the PSAP. So you see it's really a lot. There are really 233. And on the left side, this graphic is a well-known graphic of the EENA PSAP guide. In Germany, we don't divide between stage 1 and stage 2 PSAPs. You call 110 for police or 112 for all non-police emergencies, like we say in Germany. But the graphic is not completely correct, as we have 112 for both fire rescue and emergency medical services. Yes, some words about PSAP in Freiburg. We are responsible for an area with a population about 500,000 people. We have about 100,000 112 calls a year. That's an average value for a typical German PSAP, I guess. Our PSAP is integrated in the main fire station. That's a big advantage for us if we need additional call takers in a short term. For example, if a thunderstorm is beginning, so we always have enough staff here in a very short term. We have our own data center within the building running 24 hours, 7 days a week for hosting the CID and other technology for the PSAP as well as for the fire station. So we have best requirements for provide the German AML endpoint. The German AML endpoint is here in our PSAP. The federal states and the federal government assigned our PSAP to provide the endpoint for Germany in 2019. It's not extraordinary as it sounds that a PSAP is providing the endpoint. I know there are some other countries too. So that was the idea to provide the endpoint here in Freiburg. There's a passive redundancy system in Berlin, but it's only a passive system. So at the moment, all messages going directly to Freiburg. At the moment, over 230 PSAPs have access to the AML endpoint. So you can say all PSAPs in Germany have access. They are only missing 2 or 3, and I guess they will join soon because they're just renewing their technology. At our endpoint, we receive 60,000 HTTPS messages and 80,000 SMS messages per day. The difference is logical because not every caller has mobile data activated, but at all, of course, it's a lot. Our ELS config is configured with 3 messages per emergency call. So the first message directly with the start of the call, and the second message after 15 seconds, and the last message after 30 seconds. We started a test with permanent messages for the whole emergency call some weeks ago, but we still analyze the benefit from it. Now I'll show you a short animation how the AML is integrated in our PSAP application, in that case in our communication system. I will start the animation soon, but because it's in real time, so it's the time is very short, I want to say some words before. After the start of the animation, you see the location data of the cell first provided by the network. We receive the location by the network directly with ringing of the call, but as you will see, it's very inaccurate. Then it will take about 2 seconds, and then the first AML message is received. You see the accuracy will be much better then, but it will be still 1,000 meters, and then the second AML message is received some seconds later, and then the accuracy is very accurate. I will start it now. That's the cell. You see, very inaccurate. That's the first AML message. 2 seconds later, still 1000 meter accuracy, but now it's getting very short with 60 meter. So that's, as I said, it's real time, so we get the location data of emergency callers very, very fast. Here we start again, 1000 meter, and then, by the way, it was a call of me, of course, that's why my name is here, and now the 60 meter. Yeah, let's say something about the statistics. As I said, we started with AML in 2019. At the beginning, Google increased the rollout step by step. We started with HTTPS only and activated SMS end of 2019, autumn, winter. And that's the peak you see here when it's increasing much more. That was when the SMS was activated. And at the same time, Apple activated AML. And now, at the moment, we have around 75% of all mobile calls to 112 with AML data. And as you see, it looks like it is still increasing. So I'm still hoping that we one day perhaps we'll reach the 90 or 95%. That's a statistic for Freiburg only, not for the whole country, but in other regions it's very similar. For us, it was very important to deploy AML in a privacy-friendly way, because the trust of the people is absolutely fundamental. That means we delete all data on the endpoint 1 hour after the call. We refuse not necessary data like IMSI or the device model, because it's not necessary for the emergency call for us. And very important, the device number is only stored as a hash value in the database. Here you see the data flow. The caller sends the SMS or HTTPS message to the AML endpoint. Of course, the SMS goes to the SMSC first and then to the endpoint. And the location data then goes to the PSAP by HTTPS. But very important, the PSAP starts the request to the endpoint. That's only the data flow. The PSAP starts a request to the endpoint with the device number as a parameter. So it's a pull and it's not a push. I will come back to that in the next slide. Here you see the handset is initiated the 112 call, and it goes, of course, directly to the PSAP. The PSAP then starts requesting the endpoint with the caller number. And in that case, there is no location data at the endpoint, so they will receive no location message. Then after some seconds, they start the next try. And you see here, in that time, the first AML SMS is received by the endpoint, and the first HTTPS message is received by the endpoint too. So the next request from the PSAP will be successful. Then after some seconds, they will try again, start the next request, because as you saw before in the animation, as longer as the call take, as better is the accuracy. So it makes sense to request the endpoint permanently. The PSAP has access to the endpoint by an API we provide. So as I said before, every PSAP in Germany is independent in their technology. So there are a lot of different CAD systems and communication systems. And but every vendor is able to start the request to our endpoint by the API. And as I said before, the parameter is a caller number. So the PSAP or the system, of course, of the PSAP, they use the caller number as a request parameter. And that's it's very significant that we have a correct device number in the AML messages. As I said it before, that the HTTPS messages often don't have a device number. So in the one of the later slides, I will show you how we match it. Yes, cybersecurity, of course, is always a big topic, especially if you open your network to the internet. So if you provide an HTTPS endpoint for AML, it's necessary to open your network. Of course, not the inner network, but you need a network to provide the HTTPS endpoint. So we have some risks to handle, but it's possible to deal with it. I will not go into detail because this webinar is not about cyber security, it's about AML. But let's have a short look at the risks I give here as an example. If the attacker uses malicious code injection, SQL injection, or something like that, a very easy measure is check the ELS data for compatibility. And if it's not compatible, refuse the incoming message. For example, in the device number, the device number may only include numbers and the plus symbol. You see here, that's a device number. So if, for example, in the device number field, there would be a semicolon or a letter, just refuse it. The same in the location latitude, it may include a dot and numbers, but nothing more. Of course, there are other risks like DDoS attacks. A very good measure against it, it's a very important measure. Isolate your HTTPS endpoint from the SMS server. So if there's a DDoS attack, perhaps you will not, the HTTPS server will not be available, but then you still have your SMS server. And of course, another problem could be fake or break data. It is more easy to send a fake message by HTTPS than by SMS. But for us, it's no problem unless the ELS data is associated to a real emergency call. So the attacker has a big problem as he or she doesn't know the device number of the real emergency call at that time. And if the number isn't known, there's no chance to associate the real call with the fake HTTPS message. So we receive the fake message, we store it in the database, and after 1 hour, like every message, it's deleted. And the probability that an attacker uses a real number is, of course, it's very, very low. As you see before, we receive 80,000 AML messages a day. Now let's see how we match HTTPS and SMS. As I said before, the device number is significant for us. So if we receive the HTTPS message without a device number, we can match it with the SMS and we do this by using the IMEI as a key. We consider two cases in that diagram. The SMS message is received and the HTTPS message is received. Let's have a look first at the SMS message. The SMS message is received by the endpoint and it's directly inserted in the database. That's the first step. In the second step, if it's an SMS from Android, because the Apple SMS, we don't have to merge with HTTPS because Apple doesn't use HTTPS. So if it's an Android SMS, we update in the database all rows where the IMEI is like in the SMS with the correct device number, with the device number of the SMS, because the device number in the SMS is always correct. On the other side, if we receive an HTTPS message, maybe the device number is not available, here it's 0. We start a select on the database and select all data sets where the device IMEI is like in the HTTPS message. If there's no row, we insert the HTTPS message in the database and wait, perhaps some seconds later an SMS is received and then the dataset would be updated. If there exists a row, we use the device number from the existing row, overwrite it in the HTTPS dataset and insert it to the database. It looks more complicated, but in real it's very easy. Here we see the two datasets in the table form view. We see the HTTPS message with no device number, but with an location altitude and an device languages field. On the other table, we see the SMS with a device number, but no altitude and no device language. And here, after we merge it, we have both. So we have a complete data set with the advantages of both SMS and HTTPS. For example, the device language is in my opinion, a very important feature of ELS, because with the device language, you can transmit the caller directly to a suitable translator, or perhaps use automatic translation systems in future. But for now, for me, it's not easy to understand if the caller is from Poland or he's from Czech. Or for me, it sounds very similar. So it's a good help to see the device language, like here in the example, it's Germany and Poland. Another important point for HTTPS, of course, is roaming. Alastair said it before. HTTPS is a very easy solution to provide AML for roaming caller, because a lot of roaming caller, they have activated their mobile data, and the data volume of the dataset is very, very small, so the costs are not significant. And I can say from our endpoint statistics that about 5% of all HTTPS datasets we receive are from roaming callers. So as a conclusion, I really recommend using both SMS and HTTPS. And now I lead over to Alastair again. And as I said before, there will be time for questions later.
Awesome. Thank you so much, Henning. Yeah, that was really useful. And it was also great to see. I love that slide 2 slides ago where I think you showed the benefits of the merging of both, seeing that you can get the benefits of both of these fields thanks to the the little algorithm that you discussed. So I'm just going to share. Let me just share. Is that working? Yes. Okay, let me find the button. Cool. So yeah, the next step, we've only got 1 or 2 slides left, and then we're going to open up the floor. But getting started, what's the next steps? I really hope that we've kind of given you this. Wait, can you see it properly, or is it actually really zoomed in? Let me just see.
It is very zoomed in.
Oh, interesting. Let me resize my screen a tiny bit. I'm going to stop presenting and I'm going to re-present because I think something went horribly wrong. Okay. Okay, that looked a bit better.
It is
there we go.
fine now. Yeah, thank you.
Awesome. So yeah, getting started. What are the next steps about this? I really hope you've seen some of the benefits of HTTP and SMS working together here, and the pros and cons of both. But hopefully, these are the kind of things that will help enrich your current solutions today. To like I said, back to that original goal that we discussed, provide more and more help and more matching in more matched ELS data to your incoming emergency calls. And so yeah, so we've basically just got this takeaway slide here. And so as you can see, matching on IMEI can be done today. There's the spec is ready, the IMEI field exists in both the protocols, and so you can go and do this today. And as you've seen, lots of benefits, including the speed of HTTPS, the roaming support of HTTPS, the setup challenges. It's not as hard to set up as it might seem, and even performing the matching, as you saw, there was only actually, the diagram's quite simple, really. If there's a phone number, check to see if there's a phone number. If there's not a phone number, to check to see if there already was a phone number. So this is the sort of thing that you can do already. And hopefully in the coming years, additional emergency information, we're going to be providing more and more useful fields as part of the this HTTP spec. And so we really hope you can get migrated over sooner, so that once these fields start becoming available, you can start getting all of those benefits. And like we say, there are fields already like device language and other ones that I think are really useful, altitude, that are useful to get out today. So actions, I guess, if you're interested, please reach out to Android Emergency Location at google.com. We can discuss any kind of questions you have, rollout plans, timelines, and basically we want to support your needs. I think something we're also very open to here is we want to get your feedback, and maybe there are things that you would like from us. So for example, let's say you're interested in, let's say you have a challenge that SMS costs a lot of money to run. There are potentially options here where the benefit of HTTP is we can send a lot more HTTP messages, and it doesn't really cost that much. It's very, very small amounts of data being transmitted. Whereas SMS, there are limits to the amount you can send, really, because that can quickly stack up. And so we're open to potentially piloting the idea of, even in some scenarios, maybe we send less SMSs, and then you do matching on the HTTP, which you get a lot more of. And we're open to your thoughts and observations here, and willing to do some pilots to see if this allows you to kind of enhance your solutions, whilst at the same time making it more possible for you to make your current approaches sustainable. And so please reach out to us. We're really happy to chat, as we really believe in this, and we really want to try and help get more partners onboarded with HTTP, most importantly with matching. And then the next thing is read our dev site. We've got a developers.google.com/android/ELS. If you don't have access to that, please email the above email address. You may need to go through some steps to be able to get access, but we're going to be updating the documentation website with some of the information, like the presentation, like maybe some of the presentation today, so that you can have some of this for reference. So maybe any of your engineering teams can more easily just, look at the specs. Like, the benefit of HTTP as well is it is a really simple spec. It's literally just an HTTP post request, and I would imagine most kind of people with any familiarity with web development would understand that straight away. So read our dev site. We're going to be updating it in the coming weeks as well, and we'll notify you once we've done that. But yeah, we're really looking forward to hopefully this has kind of sold some of you on the benefits of HTTP, and hopefully we'll be talking to you soon and trying to get more of you on board. And I guess, yeah, the next slide, we've got a bit of, oh, there we go, questions and discussion. So I'm gonna probably stop sharing my, I'll stop sharing my screen now, and then we can open it up if people have any questions or observations or things like that.
Thank you, Lester. And actually, as a first question, so I see many of you have used the chat to ask questions, which is great. And actually, one of the topics that was really recurring was about roaming and whether this works when roaming, how, with what success. So if you can please elaborate on that first.
Yes, so there are two ways to do roaming with SMS. There's one way where you set up a long number, which basically includes the country code. The challenge with this is you do need to set up a long number, and also the actual text message has to jump multiple hops. So let's say I'm on a UK phone in Germany, making an emergency call in Germany. The text message will actually go to the UK, back to Germany, and then to the emergency call center. And so that is a much longer route, and it can often see high error rates. Whereas there's another approach we call the Orange Belgium approach, where you basically work closely with one of your MNO within your country so that the SMS never leaves the country. But this also, it improves the error rates a bit, but it's a lot of effort to get set up, and it still has generally higher error rates than HTTP. The benefit of roaming for HTTP is if the user has access to the internet because they're roaming data plan, which is very common in Europe these days, there's actually no extra setup required. We will have to configure it on our side, but generally it's pretty quick to do. No extra effort on the partner.
Thank you, Alastair, for that clarification. There's actually another question that I saw was quite recurring, and I think it's good if we make that clarification, is asking whether the email is actually anonymized in the ELS fields.
Yes, so there are two fields. There's IMEI and IMSI. Now, both of these fields exist in both the HTTP and the SMS protocol. However, the SMS protocol IMSI is anonymized, so you won't be able to match it onto the HTTP message. But the IMEI is the device identifier, and so that is matchable between the two messages.
Okay, thank you, Alastair. And then I saw another question in the chat was about whether, Henning, you have some stats on, like, let's say, the success rate of the matching of SMS and HTTPS with the call.
Yes, I see that one question before, if the IMEI is anonymized in Freiburg. I just checked it because it's on my to-do list for a very, very long time, and until now it's not anonymized, but I will anonymize it very soon, because it's of course for us it's possible at the endpoint to anonymize it. Then question, Benoit, you asked was the current match rate in practice when matching SMS and HTTPS. I don't have statistics about that, but when I look at the database, I guess it's very, very high, because almost for every HTTPS message we receive an SMS. So it's only 1 or 2% of the caller send HTTPS only and not an SMS. Okay, thank you, Henning. I see all the questions and comments are being made in the chat. So I see one comment from H. I'm sorry, I don't have your full name. I would like to emphasize the cover issue that HTTPS has a significantly less coverage than SMS, because indeed in Europe there's still a lot of places where we have only 2G, for instance. Thus, not giving up SMS is highly recommendable. Of course, we're not here to say like you should completely forget about SMS, and HTTPS is the only way forward. I think what I take as a takeaway from Alastair's and Henning's presentation is actually that you can use both SMS and HTTPS, and in the cases where HTTPS works, and so you can get additional data by matching SMS with HTTPS,
So it's not about like, giving up one for the other. It's more about how to use both. Then there was a question from Sven Brun. Is the phone number sent in the HTTPS when the phone has eSIM?
Yes, so this is something we're actively looking into at the moment. From what we've seen, I believe it really depends. We've not seen necessarily signal that it always works or that it doesn't work all the time. So I don't think we have any concrete statistics yet, but it's something we're actively looking into.
Okay, thank you, Alastair. Then there's a question from Deroyd. I'm wondering if it's Martin Deroyd, maybe. How can you identify that data sets are received from roaming caller?
There are fields in the message, in the HTTPS message, about the mobile network code and the home country code, and that we use for the statistics.
So just to add on to that, also in SMS, it's possible to detect a roaming call because the IMSI, we mentioned it's anonymized. It's actually only beyond the first 6 digits that are anonymized. If you use the first 6 digits, this actually gives you the MCC, MNC of the SIM card. And so you can also use that to detect an SMS. But I guess on SMS, you also know because the phone number will have a different country code on the incoming, on the actual device number. But yeah, as Henning said, HTTP, there's fields for that.
Thank you for the clarification. I see one more question from my colleague, Gary Machado. So how can we match the email if the SMS in roaming is not delivered to the visited country, thus not matchable with the email in the HTTPS?
Yeah, so this is again, it comes back to the, so first thing to also just be clear here, HTTP does have the phone number sometimes. It really depends per country. And if you're interested in learning more about this for your individual country, please reach out and I can get you the statistics for that. So there will be cases where the HTTP will have the device number. And so for that roaming case, you're good to go. And but you're right, there will be scenarios where maybe that message doesn't actually make it to the endpoint, or it might take a lot longer. And so, as we said, the error rates for SMS on roaming are high, but they're not impossible. And so, we're playing a lot of a game of statistics here, and how can we optimize? But you are correct. It is why it's important to have both and try and do the matching the best that you can, really.
Okay, thank you, Alastair. Is there any more question? I see one from Vincent Geoffrey. So in Germany, is your algorithm able to handle both Android and iOS? Do they provide similar information? Is it the same algorithm? How long does it take to sort them out, then to get the caller's location information, etc.?
Yes, it's the same algorithm. We just divide between Apple and Android SMS because of if it's from Apple, the SMS, we don't have to do the database select because iOS doesn't send HTTPS messages, so it makes no sense. The info is very similar, and we divided for our statistics that we see how many SMS we receive from Android, how many we receive from iOS. But it's the same database, and for the PSAP it's not important. They don't have to request a special request if it's from iOS or Android. They start the request with the device number and get back the location. And how long does it take? Only seconds.
Thank you, Henning. I see a question from Frank van der Laar. Does Huawei has AML HTTPS implemented? They do have AML SMS implemented, and that is working in the Netherlands. I'm not sure we have the answer here, actually. And actually, that brings me to one point. So some of you might be familiar, some not, that we have European legislation that now all the phones sold in the EU must comply with, and that legislation says that all phones sold in the EU should comply with the ETSI standard on AML, and that standard has recently been updated, and a bit higher in the chat, Freddy has shared the last version of the ETSI technical specification 103625, so you can always also refer to that. I'll ask you a final question, actually, Alastair. There are talks, let's say, about possible in the future third transmission channel, which would be SIP. Is that something you're working on or having in mind for your strategy?
Yep, great question. Yeah, we're really excited about SIP. We do really believe that this could be a really great future kind of pipe to get this data to the emergency responders. For now, there's a lot of work to be done on both from the specification side of SIP. For example, SIP doesn't yet support any of the additional data that we talk about, and there are other kind of challenges. Also, there's an adoption barrier here. It's going to take a little bit of a while to kind of bring that level of adoption up, particularly on the cell carriers to be able to support this. But there are active efforts that SIP is now starting to send emergency location, I believe, in various forms on different mobile devices. So hopefully, as that spec evolves, that's going to be a really great thing that we want to work on. But at least for now, we still believe that HTTP and SMS are going to be with us for at least the next few years. So it is important investing now, because there's still a lot of benefit to be had from these technologies. Okay, thank you, Alastair. So thanks a lot for your time. It is just 5 p.m., so we're just on time. Thanks for your explanations, Henning and Alastair. We have a lot of things to take from that, and I saw that you put your contact details on the slide, so it will be easy to basically move forward. And also to help you, so this call has been recorded, and that recording will be shared on our website in the next days. It's on eena.org/AML, and so I will not spam you with the recording again, but so just stay tuned, and you'll find all the information you need on our website. All right, thank you for your time. Have a great evening, and see you soon. Thank you, everyone.